Hello and welcome. So today we will be coding using the bagging and boosting libraries. I hope you can see my screen. So I want you to load this data, Abalone data. I think you would have seen this in Decision Trees week last week in one of the recordings. So what I'm doing is I'm going to paste this link in the chat, and you can use pd.readcsv to load this.
Ma'am, chat does not work because we can't copy from chat.
Oh, is it? You can copy from chat, is it?
No, you can open it, you can click on it, but you can't. Okay, maybe clicking will work, I think.
Yeah, you can click. One second, let me. Yeah, you can click on it, and then from there you can copy paste. Okay, so this is the link. Use pd.readcsv to load this data, and then give you the column names. So if you go to the documentation of this data set, you will get the column names from there. And then you can keep that in the form of a list. And this list you will be passing when you will be calling pd.readcsv. So okay, you would not be able to copy this thing as well, right? Where do I paste it then? Okay, I'll give you 2 minutes. Just you can write this down, the column names. Or if you can go to the documentation and from there you want to copy paste the column names, that also you can do. Okay, so please import these libraries, pandas, for loading the data. Matplotlib, we might require if you want to plot something. You can skip it for now. And Seaborn also, you can skip it for now. And then NumPy you can import. And then you go ahead loading the data. So column names I have given to you in the chat. You can take from there. And then I'm loading the data using pd.readcsv, and then I'm passing names of the columns using names is equal to column names. This is the list. So please let me know once you load the data, and then we'll go ahead. So how many samples are there in the data?
4176.
4176. 4177, right? Or 4176?
No, first I loaded without the header, so that is yeah. I have to get one more.
Okay.
The writing, we are just still writing the full list, so I have not done with the header.
Okay, okay. So I hope it is clear to you that sometimes in the CSV, the first row contains the names of the columns. In that case, we put header is equal to 0, which means the index of the row to be taken as the column names. And when CSV doesn't have the first row containing the columns, we write header is equal to none. And we pass the column names explicitly in the form of a list, which is what we're doing here. I hope you have done till this point. And then you can see the shape, that is the number of samples and features by using shape. And this is what we get. So there are 9 columns. So one of them will be the target. So in case of Abalone data, the ring column, which sort of indicates the age of the abalone, is used as the target. So that leaves 8 columns to be used as features. Please let me know once you're done till this point. And sometimes you might wonder how is it that we can check whether the CSV contains the first row having the column names or not. So what you can do is you can just simply load it, and then you can call the head function to see the first 5 rows. Okay, so that can give you an idea about what you're getting as the first 5 rows. Okay, and in case there is a first row having the columns, you will get it from there, and then you can go back and modify your pt.read CSV command. That's how you do it. Because sometimes the CSV is small that you can open it and see its contents. But in practical scenarios, these CSV files are very huge and you sometimes are not able to open it. So you can do that using code, and head only accesses first 5 rows. So that way you can manipulate and learn more about the data without even opening the CSV file. Okay, can you please confirm if you should go ahead? Are you done till this point?
Yes, ma'am.
Okay. All right. So there are 8 columns, 8 features, except the target. So I want you to see and tell how many numerical and how many categorical features are there. Okay, that's the first thing. Let's check and you let me know. Oh, you have written in the chat. I just now saw. Sorry, I somehow don't get the notifications of this chat. So maybe you can consider speaking up. Okay, so how many numerical and how many categorical features are there?
Yeah, I said 1 categorical.
Yeah.
Rest are numerical. The first
Correct.
one is, yeah.
Correct. So there is 1 categorical feature and the rest are numerical features. Now, can you tell me if you have to perform some pre-processing when you have a mix of features? How do you do that?
Each column, right? So one that apply a different preprocessor to the categorical column.
How do you do that?
Oh, that is my dread column transformer. It's,
Yeah, correct. So have you done that?
the first week we did it. It was
Yeah.
For me, the thing is, okay, maybe it's the age, right? So I don't know how the youngsters may not. If you have a mixture of open brackets, square brackets, it gets very confusing because
Yeah, exactly. Yeah.
You can't really parse it out very clearly.
So there are actually multiple ways to do it. Like you see, if you're very good in pandas and numpy, you can actually process different columns separately, and then you can concatenate them, right? There is a concatenation option.
That's what I would do. If we
Yeah.
for this, I will just take that sex allowance, the first one column separately, process it, and then put a column stack finally.
Okay. So that is one way. And then, so when you separate out one column and then you apply pre-processing on that column, and then on some other column, you apply some other pre-processing, and now you got two different columns, they are processed, and then you concatenate them, and that's how you get your training data back. So that's one way, but that gets a little complicated. You have to take care of many things. To handle that, in the week 2, you did some pre-processing where you came across this column transform, right? So we will be using that column transformer. It makes things a little easier for us when we have different kinds of features in our data. So we will do that with this data set, given that one of the columns is categorical and rest are numerical, and so they require some different kind of pre-processing. We'll do that in a while. Okay, I wanted to divide the data into X and Y. As I told you, rings is the target, so that will go to Y, and everything else will go to capital X. Please do that division. You can do that manually.
Ma'am, here we can use pandas get dummies also, right?
Yeah, you can use that also. Yes.
Okay.
Yes. So as I said, there are multiple ways, but one gets comfortable doing one or the other along the way. Get dummy, I personally find column transformer quite clean to use. The code gets very clean and very systematic. So let's do that. And if you get comfortable with that, maybe you can also do that, because this is very common use case, very common scenario. Our data is always a mixture, right? So this is a useful thing. But of course, there are other ways, as I said. Okay, so this is the object that has our data. We have to divide it into X and Y. I hope everybody by now, by week 10, everybody is comfortable dividing the data into X and Y. You can use iloc for integer location, because we will be accessing using integer indices. So, and you can access the last column using -1, or if you know the exact index of the last column, you can use that, which is 8 in this case, right? Yeah, that's 8. Or you can just write -1. Once you're done with dividing the data into X and Y, you can go ahead and divide X and Y into train and test data as usual, using train test split and using the random state to be 0. Please let me know once you are done dividing into training and testing data. Okay, please take test size to be 0.2. Please take text test size to be 0.2. Okay, so just to have a peek into the data that we have, you can simply call head, and it's a good idea to just take a look at the initial few rows, which I'm doing by taking a look at the first 10 rows. And you see these are the rings. So they are discrete values. So we will be using classification on this data. And this is the categorical feature that we have, and all rest of the features are numeric. Okay, so this is how we divide into X and Y using ilog. And then using train test split, we are dividing into X train and X train X test, Y train Y test. I hope everybody is reached till this point. Okay. Now we want to use column transformer, given that we have a mix of types of features. We'll be using column transformer, which requires lists of categorical features and a separate list for numerical features. So we will first create them. We'll create two separate lists, one for numerical feature names, another for categorical feature names, because we will need to pass them in the column transformer. So we will keep them ready.
Ma'am, I had one doubt in pandas.
Yeah.
Like suppose we have a data set with column headings, then is there any way to get those column headings without explicitly writing a list? Because if the data, like number of features is large, then it may not be feasible to write each of the column names, right?
Yeah, so you have this header
Okay,
parameter, right?
header and one. But I think the issue is it's still like I tried, but I couldn't convert it into a list type.
Sorry, didn't get your question.
Like if I want a list of columns, like header will still give me a data frame object only, right?
So what is your objective? You want to get a list of column
Yeah,
names.
like to do all these manipulations of splitting
Okay,
and
pandas actually has pt.get column something. There is a function you can directly get the column names.
okay.
Yeah.
I'll check that out. Yeah, thanks.
So if let's say PD is the name of your data, then pd.columns. Can you try doing that, Shreya?
Yes, ma'am, I'll check it out just now.
Yeah, pd.column should give you the list of columns, and then you can go ahead creating these two lists. Okay, so I hope you have got these two lists. And now, so in column transformer, what we can do is we can pass a separate pipeline for numerical features. We can pass a separate pipeline for categorical features. So pipeline we would require if we want a sequence of operations. If we want just one operation, we would not need a pipeline. We can simply pass an object of the pre-processing that we want to perform. For example, here in this case, for categorical features, we want to let's say do one hot encoding. That's all, right? That's all we want to do. And for numerical features, let's say missing values are there. So in that case, we would first want to handle them using, let's say, simple imputer, and then after that we want to scale them, let's say using standard scaler. So there are two things that we want to perform. So on numerical features, we want two things, one after the other. On categorical features, we want only one thing, which is one hot encoding. So for numerical features, we can create a pipeline. Okay, that's what we will be doing. So I wanted to create a pipeline for numerical features that replaces missing values. Week 9 decision trees, this collab was used, this Avalon data was used, and there we actually checked in detail that the missing values are not NaN or question mark, they're actually zero values. There were some zero values there that we got to know after doing some exploration. So that exploration part I'm skipping here because that you can see there, and it's already covered in those slides, in those videos. And we also got to know that the missing values are pertaining to I sex, which I stands for infant. Okay. What we did was we found the mean value of mean value of all those columns that had I as 6. So that's what we replaced with the missing values, which was 0. So I want you to do that now. I don't want you to compute this. I'm providing you this. So I want you to, in your simple imputer, I want you to replace the 0 values with this value. Okay. And then I want you to use standard scalar. So these two parts, simple imputer and standard scalar, will become the parts of your pipeline for numerical features.
So you're just asking us to create that pipeline alone.
Yeah.
So make pipeline also will work, right?
Yes, yes. So pipeline, I hope you know that you can create using two ways, right? One is just use the constructor and then pass on the steps in that. Or you can use make pipeline. You can use either of these two. By the way, I heard that some diploma students are going to IIT Madras this weekend. So anybody out of you is going there? Just wanted to check.
No, ma'am. It's I actually wrote to them also. Like 3 days is just too short a notice for people outside.
So you were, yeah, exactly. That's true. So when were you informed about this?
Yesterday was the first mail that I saw. I don't know whether there was some other information, but
Yeah.
I mean,
we got
informally,
mail yesterday.
informally I know, but I just made a thing that formally I know only yesterday. So
informally, you know that this is going to happen on this weekend only. You knew earlier?
Okay, I will not answer that question.
Okay.
But
No,
yes,
obviously I understand if yesterday you got to know, and if you're far away, you need time to, make your arrangements. Yeah, but I don't know whether you, informally knew about it so that you could make arrangements. That's another thing. I don't know about that. Okay, it'll be good actually if you people are going there and meeting instructors. All right, so pipeline, I hope you're creating. You would need to import standard scalar and simple imputer, and your strategy would be constant, right? Because you are replacing by constant value. And your missing value it is a missing value attribute, that will be 0 in this case, because by default it is not a number. In this case, you want to replace 0 values.
So do we have to put both fill value and strategy equal to constant, or just giving fill value will be enough?
I think you have to give constant also. Yes, you have to give strategy, and when you give strategy, you have to give fill value. Although it should be implied that when there is a fill value, the strategy should be constant. I understand, but I think it expects.
Okay, and then we are not doing any fit transform yet because we will apply the column transform. Right? We're just creating the pipeline.
Yeah, we'll do that in a while. Wait for that. And for categorical features, I want you also to create an object. If there were, let's say, 2 operations that we wanted to perform on categorical, then we would have created a pipeline for that also, a separate one. But we just need 1 operation. So we'll create an object of one hot encoder. So please import that also. So here I'm importing some libraries, for one for pipeline, one for column transformer. Okay, let's wait for you to finish first. I hope everybody present here is coding.
Ma'am, any reason why we prefer one hot encoder over label binarizer?
Label binarizer, I think it doesn't. So there's not. So one hot encoder, what it does is there is only one value which is hot. That is 1, right? Label encoder, I think. Let me cross check.
The sparse matrix.
Sparse
No,
matrix
actually,
is given by one hot encoder, right?
actually, label binarizer is for when you do something on the label, not on the features. So
Acha,
if
okay,
you are
okay.
using label binarizer on a pipeline, you won't be able to compile.
Correct, correct. Label is for target, right?
Yes,
And
Okay,
it has to be the target feature.
yeah,
Okay, got it. I got confused. Thanks.
yeah, it's only for target. Yeah, Rajiv. Correct. Okay, are you done till this point? Creating one hot encoder object also, and this pipeline.
And the
Are you done till this point?
Yes.
Okay, okay, thanks. So one hot encoder also you create for the categorical feature. So we are just calling it categorical transformer, and we're calling numerical pipeline to be numerical transformer just for uniformity. Okay, after doing this, so now let's say we have created two pipelines, one for numerical, one for categorical. Now the next task is to create a column transformer, right? This column transformer has to take into account these two different operations, which will be performed parallelly, and then the results will be concatenated. So that's what is the task of column transformer. So please import column transformer from sklearn.compose library. Okay, now let's create an object of column transformer. I hope you have imported that. We'll now create an object of column transformer. We're calling it preprocessor because will be preprocessing our columns. Now in this, what we pass on is a list. Transformers is equal to a list. Now this list will be the individual transformers, that is individual pipelines that we have created already. There are three things. So basically this is a tuple, and that tuple contains three values. First is the name of that transformation that we are applying. Second is the object of the transformation that we have created, that is the pipeline that we would have created. Third is the features on which this transformation should be applied. So we have such tuples, one for numerical features, the other for categorical features. Every tuple will have three values: name, object, list of features. Okay, that's how we will create a column transformer. Please let me know once you're done till this point, then we'll go ahead. Okay, if you're done till this point, if you have created an object of column transformer, now you understand that this is basically a pre-processing that is applied to our columns. So we are yet to apply any model to our pre-processed columns. So we can create yet another pipeline where the first object will be this preprocessor. I hope you are understanding this hierarchy. So this has become our one object that will apply the pre-processing. Second object will be the model that we wish to apply. So let's go on and use bagging classifier as that model that we want to start with. So we'll create a pipeline now to first pre-process using this column transformer, and then applying the bagging classifier with default values.
Yeah, just I'm getting trouble with the column transform again. So the numeric features that you have, the type is a list.
The type is a list. Yes.
Yeah, I'm getting an error that it's not a list. So let me just debug that.
Can you just explicitly type bracket and then this name? What is the type that you get?
Okay, I'll do that. Yeah, let's try that.
Yeah.
I've used different variables, but I get an error saying list is unhashable. And numerical column is the list of numerical columns. It is a type of list. It is of type list.
Type is list. Okay.
Sir,
Yeah.
you've used flower brackets in the first argument. That's
Oops.
treating it as a dictionary.
This bracket.
Okay. Sorry. Yeah. Got it. Thank you. Sorry. Silly error. Sorry.
I will share which. Okay. Have you copied?
No, in his code in the chat box.
Okay. Let me check. Yeah. All right. What kind of brackets have you used? Okay. All right. Yeah. So first and second bracket, they are wrong.
Got it. So now I proved that I do. I mean, that's a silly error, but I do get into this trouble with the brackets.
No, but at least you do it, and then you get to know. There are many people who don't even try. So
Yeah.
next time,
Thanks,
you
Shreya.
error. Yeah.
Thanks, Shreya, for pointing it out.
Yeah. And if you try typing anything in chat, please let me know. Then only I check. Okay. So where have you reached? I hope you are done with the column transformer, and the next step is to create a pipeline where the first object will be this column transformer, and the second object will be a bagging classifier with default values. Please let me know if you have done this.
And this is ensemble, right?
Yes. Bagging classifier is an ensemble. Yeah. sklearn.ensemble import bagging classifier.
Okay, done. Yeah. So printing that pipe seems like it prints the original pipe also, right? So a lot of printout.
Sorry, which original pipe?
No, I created the pipeline. I just printed it, so it actually gives a column transformer also, and then the bagging classifier, and then that itself has another pipe. So it prints
Yes.
all of it.
Yeah. So if you understand this very step, it gets very handy whenever you quickly have to analyze some data, because this is a very common scenario. And I personally find it very clean. As I said, using the column transformer gets very easy. Just decide which transformations you want to apply, which pre-processings you want to apply on your data, different kinds of data. Then you have to see whether which thing should go parallel, which thing should go sequential, right? Once you know that, you know the steps. Okay, so I assume everybody is done till this point. Now,
Yeah, one curious question, if I can ask.
Yeah.
How do I, if I want to really badly access the simple imputer? So can I do that with the multiple pipe commands?
Yeah, so yeah, you can do that. So there is named there is some.
Yeah, so will that work? So can I say
that will work.
CLF preprocessor dot that
Named
pipeline?
steps, no? Named steps. So this
Okay.
is the name of the preprocessor, and then you should go inside that. Inside that, you have named this one num, right? Your numerical transformer. And then inside your numerical transformer, your namings are like imputer. So you have given name to every object.
So separately, it'll be dot, right? Not a multi-dictionary.
No,
So
no,
I have to
multi-dictionary. It should be a dot. You can try that out.
Okay, CLS, this thing, dot, that, dot, that.
Okay. You can try that out and let us know, Srinivasan. Meanwhile, others can go on and train your model using the training data, which you already had, and check the score on the test data. Let me know what score you're getting on this.
Okay, so now if I try to do the fit, it is going to do the fit of the pipeline, everything, right? I get some error somewhere in the pipeline. So
what is the error that you're getting?
Could not convert string to float. Maybe some silly mistake I may have made. I have to go debug that further.
So you did this, right? The pipeline object, you called fit on that using xtrain ytrain, right?
That's right, yeah.
Okay.
I think must be because we didn't do any fit, right? So then some of the pipeline initial ones may be wrong. So I'll have to go debug one by one.
Okay. So what exactly is the error? Maybe you can type in chat. Did anybody else finish this, or did you get an error?
I'm getting a different error actually.
Okay.
It's saying numpy object has no attribute check fit params.
Could not convert string to float I. So I is the okay. I is the one of the values in sex feature. So there are three things in first column, M, F, and I. So could not convert string to float. So looks like your one hot encoding hasn't happened. Can you check that part, please? Because I is there. And
Yeah, that's what I'm doing. I one by one. I'm trying that encoder.fit. Yeah.
Okay. Shreya, what is the error that you were getting again?
I'm getting an error. Okay, now actually I went back to the data frame. So it's saying data frame object has no attribute check fit params. I can put it in the chat box as well.
Are you calling this function fit params?
No, it's just I'm doing dot fit only.
Okay. Did anybody else finish? Srinivasan, are you able to fix it?
No, I'm going one by one. Let me try.
Okay. Why, Shreya, you not this function? Only 2 people are coding, is it? What about others? Can somebody confirm if they reached in this point and were able to get this code? Shreya, any progress?
No, ma'am, I'm trying to see what's happening.
Data frame object.
I've put it in the chat. It says.
Yeah, this looks very insufficient for me to try to figure out the error. Anything else are you getting? I mean, which place exactly are you getting this? The underline you might be seeing, no?
Yeah, that is pipeline only, the last part only, because until then I checked the transformers. It was working fine individually.
Okay. So this last step is so we are simply in the brackets what we are doing steps. There are 2 steps in the list, right? There are 2 tuples in the list.
Yeah.
Is this correct? Have you done it this way only?
Yeah. I have done it this way. I'll just check. Yeah. It's fine. If someone gets it, you can probably move forward. I'll check it in the meanwhile.
Okay.
Mine was a silly error. So
What was the error?
I was calling fit on the class rather than the pipe.
class?
So
Which class?
no, the bagging classifier.
Okay.
I was calling fit on that rather than the pipe.
You did not do any pre-processing, right? And you were calling.
Yeah. So that's why.
Okay.
Okay, believe it or not, I think that's also what I was doing.
Okay, funny. All right.
So 0.22 is the score I get. I don't know that that's right.
So I'm getting 0.23. Is there any random thing?
Random state? What did you use? Random state? I used 42
Where
in test train split.
0 that was, isn't it?
Okay, then I used 42, so that may be the
You
difference.
use
Because
0 and then
I've seen that's where the small errors come. Like I get 0.229, you're getting 0.232, so it's not too
maybe
different.
you can make it to 0. Go back, make it 0 so that we are on the same page. Okay, so is everybody done till this point? Only 2 people are seeming to be coding along.
Yes, ma'am. 0.23. I got it.
Okay, good. 232, right?
Yeah.
Okay.
Okay, my trouble again. So I get now 0.216. So there is some issue somewhere. So I'll have to. This is typically most
I know.
MLPs.
You keep telling me, and this is this.
Yeah, I know.
I know why.
So I don't know why I get into this alone. So let me try some more.
Does bagging classifier require any? 1 second. Bagging, yeah, there is a random state required in bagging classifier, right? But Shay is getting the same thing that I am getting.
Okay, I put that random set equal to 0. I get 0.2300. I know what I have done. Somewhere in MLP, I might have not got something. So now I get 0.2300. So this is typically the range I get, right? I get something very, very close, but
see.
not right there.
Okay, can you take random state? Let's take a random state to be 0, all of us, and then see.
Yeah, so I think only bagging classifier and then test train split. Only those two need a random state, right?
Yeah, bagging classifier, and yes, so far only these two need. Let's see what we get.
And 107996 was the missing value.
That was 107996. Yes. Okay, so I'm getting 0.238.
Now I'm getting 0.2416 with random state.
Did you in bagging classifier as well?
Yeah.
Is there any place? No, I don't think any other place requires this.
Okay, I disconnected the notebook. I started again. I get 0.238.
Yeah, that's what 238. Shreya, what is it?
She got that first. Now she's getting a different value.
Yeah, now I'm getting 0.241.
Can you rerun Shreya and see?
Yeah, let me just.
Okay, 238 is what we got so far. Let's move on. This is an optional step. Let's skip it for now. Let's move on to this one. So bagging classifier, so far we did not give any parameters as such. Now I want you to use grid search CV to be able to get a good set of parameters. Now, actually, if you give a lot of parameters, it just goes on and on in tuning them. So given the time that we have right now, I want you to only tune 2 parameters with these values: number of estimators in the bagging classifier and max samples. So please try to tune these 2 parameters, and I want you to use recall as the scoring criteria, and let me know what parameters you get. One thing to note over here. So I want you to use grid search CV on bagging classifier. Okay. And then you would be, calling that, you would be fitting that, right? And then you would be using the train data. So train data so far is not pre-processed. So you may consider pre-processing your training data. Since you are not using pipeline, if you're calling grid sub CV on an object of bagging classifier itself and not on a pipeline, then you should consider first pre-processing your training data. Okay, is this point clear to everyone?
Yes, but I was thinking I could just pass the pipe as the estimator in grids. I can't do that.
You can do that also. You can do that also. You can
Should
do
work.
that.
Okay.
That should work. Yes, we have done that in the past. But here, since I'm doing that way, you can do that way also, no problems. So I'm pre-processing the train data, and then I'm doing the hyperparameter tuning with an object of bagging classifier itself. So if you want to do that, please keep it in mind so that you don't get any error. You can go either way.
Hey, can you keep that grid search, please?
I'm sorry. I was checking something further. Yeah.
A practical question, right? When I create the parameter grid, I don't know what classifier takes. So I have to look at the classifier variable names or the parameter names and accordingly create it, right?
Sorry, I didn't get your question.
See that n estimators, how do I know that is the correct name, right? I have to look at the bagging classifiers parameter list, keep that syntax in mind and then create the parameter grid.
You should consider seeing the documentation to make sure that you're using the right name. Of course, if you use a different name, that won't work, because this is what exactly will be passed on to the object, the first thing that you're passing in grid sub CV, right?
And how many, what is the CV equal to 4 or 2, 3?
CV,
You've not given that.
Not giving. So by default, can you check what is the default value? That's what will be. I'll check what is the default value. So I'm not passing. Let's see.
Default is none, I think.
And what does that mean? So earlier it was 3 and now it is 5. So let's not pass anything. Okay, so I am pre-processing the training data by using fit_transform, and then I'm importing grid search CV from model selection, and this is the param grid that I'll be passing. Yeah, you can give it a name, of course. Srinivasan, you had this doubt in one of the sessions, I remember, whether it is a list or a dictionary, right?
Yeah, this is a dictionary, no? Yeah.
So it's actually, it can be a list also. So it can be either a list, it can be either a dictionary or it can be a list of dictionaries. Okay. So in this particular case, in this list, we have only one dictionary. So it is same as you can remove these brackets also. That remains, that leaves only a dictionary. So that is also fine. Or you can also put brackets here. That means this is a list of one dictionary. Another option is you put a comma here and then you bring in another dictionary with some more, such things. So basically, let's say I give this, I'm just giving an example. Let's say I have now 2 dictionaries, right? So I have a list with 2 dictionaries, and let me change the values. So 10, 50, 100. I'm just giving some values which are not there in the previous one, just to give you some example. So now here again, I'll be giving some just some values I'm giving. Okay. Now what is happening? It will be checking how many combinations. 1, 2, 3, 4. Looking at first dictionary. 1, 2, 3, 4. 1, 2, 3, 4. 4 4s are 16. And then 1, 2 and 1, 2. 4 combinations over here. So 16 plus 4 equal to 20 combinations that you'll be trying. All right. So when you want some specific grids to be searched, you will create those specific dictionaries. Okay. Or you can have, what you can do is you can put these values also over here. That will increase the number of cases to be tried. Okay. So sometimes we do this way also. I hope this part is clear.
Yeah, sure. But I'm not going to try this in my life because I will make a mistake with the thing. So what I do is I create a dictionary. The way I do is I put in estimators as a list and max samples as a list and create a dictionary of it.
Yeah, that is fine. Dictionary.
And then just pass the dictionary.
Yeah, that is sufficient. So if you check the documentation, you can either pass a dictionary or a list of dictionaries. So both are fine. Okay, so here this is just some extra thing doing. Sometimes you want to check many scoring criteria. Then you don't need to do all this. You can just do your usual way, create an object of grid search CV, and then first object is the bagging classifier object with default values, and then second is the grid that you created, and third is the scoring criteria. And then once you create this object, you fit it on the train data. Now let me know the best parameters that you're getting. So you can get the best parameters using this property. How much time is it taking for you for tuning?
It's taking close to a minute.
Oh, okay. We should have reduced the number of parameters properly.
One of the errors I mean, not errors actually, one of the messages it showed was the value of the least labels in Y is 1, but cross validation is 5. Can you please explain what that means? Like why there is a problem with cross validation in that case?
Can you repeat the warning, whatever you get?
If I run it again, like what it meant was the least number like least number of labels itself is 1, but cross
what does that
validation
mean?
is
Least
5.
number of labels
Like,
is 1.
Meaning like if you have 20 labels and you have 5 of each type, like the minimum is 1.
Okay.
Like I have one label which is count 1, but cross validation is 5.
Okay, by default cross validation we didn't pass, so it will be 5. And okay,
so why would it show that? Okay, let me just run it again. I'll get that one.
so label is there in the target, right?
Sorry, the least populated class in Y has only one member, which is less than the number of splits.
So maybe the number of leaf is less than 5. That is the reason it is less than 6. So that is the reason it is showing.
No, leaf, I don't think it is.
See,
leaf.
for example, if in a region you have only one data point, right? In that case, how can you do a CV5? You cannot, right?
CV5 means it will divide into 5.
Yeah, but you have only one data point, then you cannot do this. Even if you have 2 data points, you cannot do this.
So maybe Shreya, you can check the distribution of the classes that we have. I know that they are imbalanced. Okay, balancing is not covered, right? Balancing, I think, will come in the next week. There are different balancing techniques. Anyway, getting back, so you can check the distribution of the targets that we have, the number of rings. It's highly imbalanced. So when there are classes, when there are classes which are very less represented, CV is equal to 5 may not work. So maybe there are classes which have very less number of samples. Okay.
Yeah, probably you can explicitly give that CV value to 1 and
yeah.
works.
So like just to be a little more precise, what it means is in the cross validation, if it goes into the test set part of it, if the least populated goes to the test set part, it won't be able to predict.
Yes, very true. You got it now.
Okay.
So yeah, exactly. Yeah, thanks Rajiv for the
thank you. Yeah.
Okay, are you done till this point? Can you tell me the best parameters that you're getting?
0.05 of samples, max samples, and estimators 500.
Okay, 0.05 and 10 is what you're getting, everybody?
I'm getting 500 as estimators.
500 you're getting. Okay, what did we pass? Let me check. Okay. We passed 10, 50, 100 and 500. Okay. Are you getting different one? What is the scoring criteria that you used?
We didn't change the scoring criteria, right?
I actually asked to use recall, but it's okay.
Okay.
No, I'll remove this one. Let's use the default one. So let me check this default one. Let's see what we get. Srinivasan and Rajiv, what are you getting? Number of estimators to be?
No, ma'am, I am far away actually.
Okay, I think you joined late. Okay.
Yeah.
Yeah, I was trying to do it with the pipe, and I'm not getting anywhere because it keeps giving that n estimator is the wrong parameter, max samples is the wrong parameter. So I will restart.
So you
I will
understand
start.
that double
Yeah, yeah.
underscore you have to put to access the individual elements, right? How did you pass it? You have to write double underscore over here.
Oh, okay, okay. For the pipe.
Yes. Yes. So I didn't want you to get lost. That's why I separately did pre-processing, and then I used only the bagging classifier and grid subsidy. But yeah, it's a good thing to try that also. If you are comfortable that way, you can go ahead. Okay, Shreya, let me see in a while. I'll get this result. Okay, if you're done with this, I want you to go ahead and in the pipeline, use the best estimators. You maybe rename, have another pipeline. The first step will be our column transformer that we have already created, and second will be the classifier, bagging classifier with the values that we have just now found, the best ones. Max samples 0.2, number of estimators, okay, 500 I have written here. Maybe that time I got 500. Anyway, random state, let's stick to 0. And let's see, please let me know what score now you will be getting on your test data.
Okay. To come back, one small thing. I have to do pre-processing both for training and test data, right?
You, for now, you're just fitting, right? If you are asking about this particular point, test data hasn't come in, right? So you only have to do for train data. Not
but before you do the scoring, you have to do the both.
Yes, correct. But Srinivasan, if you're using the pipeline, it will do the pre-processing on test data itself. I hope that part is clear.
Yeah, but the pipeline is not working, right? I'm just doing directly the classifier.
All right, then you have to do manually for both. Okay, I'm getting 100 estimators now.
Oh, okay. I'm not sure what's happening.
I hope you're doing both. We both are doing same parameters and same.
Yeah.
So I'm not passing any scoring, and yeah, that's all. I ran it again, and this is it. Max samples. How many you're getting? How much you're getting?
I'm getting 0.05.
0.05. Okay, that should not happen. 1 second. Grid set CV. Should we pass random state? Okay, Shreya, let's use point 2, not point 2, point 1 and 100 is what we were getting.
Maybe we can check the test score on both and see what it's showing.
But that will be a little different, right? Because we are using different parameters for listen.
Correct, but using like different parameters, we'll get to know which is doing better, right? Like, yeah, in this case, anyways, I think this will be the best. But
Okay, so we are getting 0.255 score on 0.248 now on the test data. Okay, shall we move on? Let's check the next one and see if we are getting the same things. Srinivasan, are you done?
I restarted it. It is running the grid search. It is doing it for more than a minute for me. Maybe I have a bad.
No, it's taking me also time. Okay, now it is finished. Max samples 0.05, number of estimators 100. We are getting. This is what we are getting as the best parameters. No, maybe we'll do one thing. We'll pass on less number of values to check in grid search because it is taking time. What is the size of the data? How many thousands? 4,000, right? So it will take some time. Okay, let's move on. We tried only bagging classifier so far. Now let's move on to random forest classifier. Without any parameter tuning, please let me know how much score you're getting when in the pipeline you use firstly preprocessor and then the random forest classifier. Please let me know how much score you're getting. Okay, we import random forest classifier from sklearn.ensemble and then we create a new pipeline with two steps. First one being the column transformer itself and second one being the random forest classifier with default values. And then we are fitting it on xtrain and then ytrain. And we are checking the score on xtest, ytest. I'm getting 0.245. Can you confirm if you got this?
Again, it looks like we need to set random state.
Yeah, that's what I do. Random state, let's set to be 0. So we should pass random state in every classifier. 256 is what we are getting, what I'm getting. So initially, without any parameter tuning in bagging classifier, we were getting 0.238. And after parameter tuning in bagging classifier, we got 0.248. And now using random forest classifier, we are getting 0.256, right? So we see some improvement. By the way, this data set, I think I told you that it's not very, it doesn't have good predictive capability, hence we are getting quite low score. But we are just trying to see how much better we can get. So 0.256 is what random forest classifier is giving us. Now I want you to do parameter tuning for random forest classifier. If you're done till this point. Okay, I need to update a few things here. Please don't mind that. So let's have small number of parameters to tune so that so that we get it quick. Let's have random forest classifier. Let's have number of estimators to tune, and let's have max step to be 4 values. Let's check 4 values. Yeah, these values I want you to check, and let me reduce this also. Okay, these 12 combinations, or maybe okay, 9 combinations I want you to check for random forest classifier. That we finish it soon. Okay, by default we got 256. Now let's do this parameter tuning on random forest classifier, and please let me know how much what are the best parameters out of these that you are getting. Okay, did you finish it? So what I am getting is max step to be 6 and number of estimators to be 50. This is what I'm getting. Can somebody confirm? Okay, one thing to do here.
I
Random
just
step I did not pass here once again. Yeah, Srinivasan. Yeah,
no,
tell
I
me.
just finished the previous one. It finished. I got
Okay.
max samples 0.01 and 10. So
Okay, good.
that is the previous. So I'm one step, 2 steps behind.
Okay, Shreya, this is another thing that we had to match, right?
Yeah.
Random state we had to, so we are passing an object to grid search CV for bagging classifier. We have to have, if you're not passing anything else, we have to pass random state at least to be able to get the same results. So
Okay. I'll do that also.
So yeah, I'm checking that once again. So here, in case of random forest classifier, okay, let's check this then. Please confirm what we are getting.
Okay, so in this case, here we're not 1 minute. So there's no pre-processing here, right? We have to pass the pipeline object in
See,
the.
there are 2 ways you can do it.
Okay,
One
okay.
way is you pass a pipeline object to grid search CV here. In that case, you don't need to do any pre-processing. But
Correct.
then in that case, you have to make sure that the parameters in this grid that you're passing, you should first write the name of that very object and then double underscore and then this parameter name. This goes for every parameter that you're trying to tune. So those things you have to take care of if you're passing an object of pipeline here. I am not doing that one here. That's why I am pre-processing it beforehand, the training data, and I'm passing simply an object of random forest classifier.
Yeah. Now, in case we have to do pipe, we have to say pipe -1. That will pick the classifier. Right?
-1 will be last thing. Yes.
And then underscore dot underscore n estimators.
No, not dot underscore.
Pipe -1 underscore n estimators. That will work.
So basically what you pass here, Srinivasan, is the name of the object. So, there are two ways. One is you access using the index. Second is you access using the name. So if you go back to the pipeline, classifier.
Okay, classifier.
Classifier is what you put. So classifier is what you should put here. Classifier and then double underscore and then NS.
Yes. Okay.
Okay. So what I'm getting here, I'm passing random state to be 0 in random forest classifier and grid set CV. And I'm getting max depth to be 8 and number of estimators to be 250. Can anybody confirm if they reached this till this point? Okay, after this, I want you to make use of these best parameters. Max depth 8 and number of estimators to be 250, and tell me what test score you're getting. I'm getting a score of 0.276, which is quite an improvement over what we got earlier in all cases. Please let me know what you got.
Ma'am, that grid search CV is taking time.
Okay.
Yeah, for me, it took me 4 minutes 30 seconds with a lot of error warning messages. Finally, it finished. So now I don't want to try it again.
What did you get? The parameters?
I will 0.01 and 10. The same as I think what you mentioned.
Oh, okay. In the previous one, bagging classifier, you're saying.
Yeah, that is when I'm finished. I'm just one step behind now.
Okay, 0.01 and 10. Same thing, right?
Yeah.
No, I got 0.05 and 500 when I used random state to be 0. Yeah, this is what I'm getting with random state to be 0. Scoring, what scoring are you using? Default one, right?
What is the value here?
So you said recall, right? You said recall. So that is what I
used recall. Okay, that's the difference. I had removed that recall. I was using the default one. Yeah, Shreya, what are you saying?
Ma'am, for the current one, 8 and 250 is what I got as well. And
8 and 250. Yeah, correct.
And the score is, I think, 0.279.
Yeah, correct.
0.279.
Oh, is it?
Yeah.
Okay, Shreya, random state. Did you pass?
Yeah, I actually did the scoring using the grid search itself directly.
Okay. All right. Okay, let me cross check. So let's keep all. Okay, I'm getting
0.2799 is what I'm getting. So
I'm getting 280 now. So Shreya, in your case, that will be CV, right? That will be average CV results since you're getting it from CV itself, correct?
Okay. I'll try the other one.
Yeah, you try this one once and let's see if you're getting the same thing. So here also we are using max depth and in estimators, right? The same parameters. let's the number of parameters so that we can quickly finish it. This is what we have done.
50 to 50, 500 and 6, 8, 10. Okay.
What did you get, Shreya? Are you done?
Yeah, it's giving the same 0.2799 only. Yeah, it's giving 0.2799.
These parameters, right? These three parameters.
Yeah.
Okay. I'm just thinking in pre-processing, what all we're doing, one hot encoding that doesn't require any random state, and then
Okay, is it because you're printing the rounded off value?
okay, that could be,
Yeah. I think it's possible.
yeah.
Yeah.
2799, correct.
Yeah, this is the-
All right. Okay, let's move on. So we tried bagging classifier and random forest classifier. Now I want you to use gradient boosting classifier and without any parameters, just use random state to be 0 and let me know the test score that you're getting.
Okay, for the previous one, 2 and 50 is the best parameters I get. Random forest, is that the right number?
8 and 250. Srinivas.
Okay, yeah,
Did
8
you
and
pass-
250.
Did you use a pipeline or random forest classifier object?
I used the pipeline. I added that. Now at least it finishes with the thing. I used 2, 5, and 10 as the depth and estimators as 50, 100, and 500.
2, 5, 10. No, we're passing something different.
Okay, maybe I got it wrong. Okay.
This is what you were passing 50 to 50, 500, 6, 8, 10.
Oh, 50 to 500, 6, 8, 10. Okay.
Okay. All right. So when we use the gradient boosting classifier without any parameter tuning with random state to be 0, we are getting a test score of 233. Is that what anybody else also getting?
Still running.
Okay.
Ma'am, random state here is 0, right?
0. Yeah.
Getting 0.242. Right.
Or is it? Why this difference again?
Only random forest problem.
Random forest, no. Gradient boosting, right?
Yeah. This one. No, I was saying only that our answers matched.
Yeah. There we matched. Yeah. Okay. But what could be?
I'm just doing the fit part again.
Okay.
Point 242 is what I'm getting.
Okay. Okay. This calls for some wider ranges for exams.
Yeah, possibly.
Yeah. Okay. Now I want you to tune the parameters for gradient boosting classifier. But not a lot of parameters I want you to try. So let me reduce these so that it doesn't take much time. Let's try this. Yeah. I want you to try these parameters.
No, Tanni. So does the gradient boost take quite some time?
Gradient boost. Yes, it does take also
No,
depends.
not even the grid, even I'm with the previous step.
Yeah, it was taking a lot of time. I also observed even without any tuning, it was taking a lot of time. Yeah. Gradient boosting, right? I mean,
Oh, one by one it goes. Okay.
yeah, different. See, in random forest, there are parallel computations that are possible, right? But in gradient boosting, it's sequential. It goes one after the other, so it takes time. Next,
And was the score?
ADA boost. Yeah, sorry.
Was the score 0.2332?
Yeah. Okay. Good.
At least I get okay. One
Yeah.
I got. Okay, I'm happy. First time.
Yeah. Okay. So GridSearch CV. Let's see what best parameters we get. Okay, we should have even lesser parameters given that it's a gradient boosting classifier, and that itself takes a good amount of time, and then 12 combinations we're trying. Okay, while this is running, maybe you can write the code for the next one. Okay, not this one. This depends on the parameters that we get from the tuning. I want you to next use add a boost classifier. Maybe you can write the code, keep the code ready. Once this computation finishes, you can check that. Add a boost classifier, I want you to use in a pipeline without any default values, just the random state to be 0. Keep this ready, and let's see how much we get. The score on test is what we're going to compare for all the models that we have tried. And then as a final step, grid search CV on ADA boost classifier, we will be finally checking. So maybe you can write the code meanwhile your parameters are being tuned. ADA boost also will take a good amount of time, given that it is also sequential. So we will try only a few parameters there also. Because this is still running.
Ma'am, what were the ADA boost parameters?
Yeah, these ones.
Yeah, thanks.
It seems to take forever.
Yeah.
Looks like even this will take a lot of time. Add a boost. Okay, there are 4 combinations only. Here we are trying 12 combinations.
How do you set the average to be macro in grid search?
I'm not doing that.
I get a lot of errors saying that the label is not binary because the label.
Yeah, okay. So which
I'm getting
scoring criteria are you using?
Putting scoring equal to recall.
You using recall? So yeah, there is. So that works only if the classification is binary. In case of multi-class classification, you put underscore macro there.
So scoring equal to recall underscore macro.
Macro, yeah.
Recall underscore macro. Okay.
Recall underscore macro, yeah. Okay, by the way, I am not using scoring criteria here. So just in case you're trying to match the results, I'm using the default scoring.
In the meanwhile, I had one doubt on decision trees. This was one of the activity questions also. Like as we go further down the decision tree, the entropy or the impurity cannot increase, right?
It can increase.
So that actually kind of, if overfitting is our concern, like we are saying that overfitting is a problem in decision trees, that will be because information gain will be maximized as we go along, right? Like if that is true, then my information gain will become like a negative value, right?
So you know, the if you talk about the what are we talking about? Impurity, right?
Yeah.
Whatever measure you're using, entropy you asked me. So entropy, whatever, when you, let's say, plot the tree, some entropy value is written in all the leaves, right? In all the nodes, correct?
Yeah.
Now these entropy values pertain to only the samples that are falling in that node, correct?
Correct.
Now it may happen that initially, let's say, if you look at the entire data set, there is a good amount of impurity, like entropy is high, right?
Yeah.
But when you split it based on some one variable, and then you look at that subset, it may happen that when you split that data set based on one more variable, you get purity, right? That may happen. Why? Because it's a subset of the data. Similarly, as you go down the tree, you get even lesser nodes, and then it may be possible that when you split them based on some feature, your entropy is reduced, as in your randomness reduces, but that pertains only to the nodes, only to the samples that are falling in that node. Okay. The entropy value that you're checking on the top at the root node, that pertains to the entire data set. The entropy value that you're checking on a particular node, that pertains only to the samples that are falling in that node. Is that clear?
Yeah, I understood. Like in terms of value, I understood, but I'm saying, like, is it not more likely that the classes will become more and more uniform as I go down the tree because of the way I'm constructing the tree?
The classes will become
in every node.
In every node, yes. See,
like What is the, I'll just give you an
Let
example.
me give an example.
Huh.
So let's say in a node there are only 3 samples. Okay. First sample belongs to class 1, second sample belongs to class 2, third sample belongs to class 3. Okay.
Okay.
There are only 3 samples, but they all are belonging to different classes.
Right.
So there is a whole lot of entropy, right?
Correct.
Whole lot of randomness, impurity is there, correct? Whereas if you go up, if you are on a node which is closer to root, you have more number of samples. The classes are 3, but let's say you have 20 samples belonging to class 1, you have 1 sample belonging to class 2, you have 1 sample belonging to class 3. Okay, you have, let's say, 20, 21, 22, 22 samples. Okay, so you are at a node which is closer to root, and there are 22 samples in that, in amongst which 20 samples belong to class 1, 1 sample belongs to class 2, and 1 sample belongs to class 3. Now if you compute the entropy of this particular thing, it will be less, correct? Because there are 20 samples belonging to class 1.
Okay.
Whereas as you go down, let's go back to the node that we were talking about. There are only 3 nodes. There are only 3 samples in this particular node. All are belonging to different classes. There's a whole lot of impurity. So your impurity has increased, right? But then that is pertaining to only the samples which are falling on that node. Correct?
Okay. Okay. Yeah. Correct. Got it. Okay. Thanks.
Okay. All right. So this disconnected somehow. It took me 14 minutes. Okay, let it be. So gradient
It's still running for me.
Okay, it's taking a whole lot of time. Let's do one thing. Let's go on. I'll stop this one probably. You can try that out in your free time. Okay, I'm going ahead, and what I want you to. So whatever best features we could get out this, we would have tried that, and we would have checked the scores on that. You can do that later on. Next, we move on to add a boost classifier quickly, and let's see with default settings, what score do we get on test data? Let me know, please. See, even one iteration of add a boost is like taking time. Why? Because it's sequential. And how many are the number of estimators by default? 100, right? Or maybe 50?
100, I think.
Right. So 100 times it would have checked, right? That's why it's taking so much time. 50 it is, Shreya. Add a boost classifier, 50 estimators by default. So 50 iterations it is taking. So test score that I'm getting is very low. 0.193 is what I'm getting. Whereas the gradient boosting was giving us a much better performance even with default values. Did anybody else get this?
I am just running the code.
Okay. Okay. So once this is done, we can tune the parameters for add a boost as I just told you. Yeah, I've just started that. Let's see what we get. Meanwhile, this is what I'm getting. Okay, this got over the add a boost with 4 parameter tuning. The best parameters that I'm getting are learning rate to be 0.7 and number of estimators to be 50. And let me put that here. Learning rate to be 0.7, number of estimators to be 50. We not round off. Okay.
Yeah, just the thing, I'm not even able to stop the grid search on grid.
You click this and whatever output you got, you click that cross maybe. This thing you put a cross there. The random state I have not given. Are you getting this? So these are the parameters that I'm getting, and for these parameters, I'm getting the score quite an improved value. Without tuning, I was getting 0.19.
93.
Yeah,
77.
193. Yeah, exactly. And after tuning, just the 4 parameter settings I've tried, as you can see, and we are observing an improvement. We are getting 0.239. So
But as people say, random forest without any tuning, it gave a higher.
yeah, random
score.
forest. Yeah. So in this particular setting, AdaBoost is not working as well. So that is why it's a good idea to check different models with default settings, and if you and then pick 1 or 2 out of them, and then try to tune their parameters. Okay. So I think in this case, bagging classifier was even performing better than the AdaBoost classifier. 0.239 is what we're getting here, and what will be getting?
But ma'am, the purpose of this bagging classifier and the boosting classifiers are different, right? All different, isn't it?
Purpose is different, is it?
Bagging classifier reduces the variance in the output,
Mm-hmm.
correct? And boosting classifiers improve the performance, isn't it?
No, bagging classifier also improves the performance.
But bagging means like
Not,
kind of
it's not that bagging classifier only reduces the variance and does not improve the output, and boosting classifier improves the output and does not improve the variance. It's not so. They both actually aim to do the same thing. They both,
but
yeah.
but in case of a bagging classifier, what you are doing, like you are selecting multiple classifiers and like getting a vote out of it, right?
Yeah, that's the way it works. I mean, that's a technique.
Right.
They both follow different techniques. That is agreeable.
Correct. So now, say for example, if majority of the classifier says that this is 1, then you will say it is 1.
Yeah, right. That's true.
Correct. Now, when majority of the classifiers is saying 1, that means the underlying classifiers are equally competent, like your bagging classifier.
Correct. So, they completely work differently. So, bagging classifier, as you said, it'll take the majority, right? The best vote. But it may happen that out of all these classifiers that the bagging classifier is, counting upon, none of them is able to handle some difficult cases. Whereas boosting classifier, since it works that way, it tries to handle the difficult cases. Maybe that one works better in this case. So it all depends on your data set. Sometimes your on some data sets your bagging thing might work better, whereas in others boosting might work better.
No, so okay, let me give an example. Say, for example, you have a simple XOR network, okay, like XOR kind of a data set, okay. You are just using a like simple classifier, no feature transformation.
Okay.
No feature transformation, so that it is getting linearly separable.
Okay.
Okay. Now both the classes, like you have 100 classifiers, they will give like sometimes 1, sometimes 0.
Correct. Correct. They will
Correct.
give good error.
Right. Now
that is in bagging, right?
No, just a minute. Now, say for example, you bag these 100 classifiers, right?
Yeah. Okay. Okay.
What it will give, like it will also give like a voting mechanism, and it will give 1 and 0. It
Correct.
will not improve the performance. It will reduce the variance in the output.
Yes. Yes.
But if you do now boosting on the same thing.
No, getting back to your XOR kind of data, right? If you, let's say, use a
simple logistic regression classifier.
Decision tree. Okay, logistic.
Simple logistic regression. Yeah, it cannot separate this guy.
Right. Let's say you use decision tree. Can you,
Okay,
want
perfect.
to consider that case, or you don't want to consider that?
No. Let us consider that.
Let us consider that case. So decision tree, if you're using it, it'll be able to do, right?
Yes.
Right. So what's the problem there?
No, like the problem is if you take the decision tree, we cannot get to the answer, because decision tree can give like kind of 100% accuracy, right?
Right. It will give you.
Right. So that's the reason I told logistic regression, because it cannot give you. It cannot linearly separate.
Yeah, it won't be able to separate. Correct.
Right.
No, I mean, coming back to your concern that let's get back to your doubt that you started with. What exactly was your doubt after taking this example?
My doubt is like how bagging classifier will improve the performance.
Bagging classifier is improving the performance, right? Because you take a subset of the data, and then some of the patterns one classifier will be able to catch, while some other patterns, some other classifier will be able to catch. So it's taking a majority of those. So it is improving the performance, right? It is improving. Oh, it is reducing the variance for sure, but it is at the same time it is improving the performance as well, right? I mean,
that's what actually, like I posted something around 9 questions on this.
you
Okay.
posted a lot of things. Yeah, that's a good thing. You're
correct, but the problem is
I'll
like
check
I
them
don't
out
get
and
any.
yeah.
I don't get didn't get any mathematical conviction that why it has to work.
Why bagging works, is it?
Not even bagging. Why even boosting works? Like main fundamental things, like okay, magically it is working.
No, it's not magical actually. It's not magical.
Yeah, so that's what I would like to understand how mathematically I can convince myself that okay, it can reduce the variance, it can improve the performance.
Okay, we can see how we can convince you. We can let me check your post, and we'll see what all how best we can explain that very thing. I mean, it's nothing magical for sure. You see that.
Yeah, of course it is not magical, because there might be certain papers and something like some mathematical background base has to be there, but it was not covered, right?
If you talk about the papers, and for sure there is a proof of the concept. For sure, when you can get the guarantee why boosting works, why bagging works. The proof of concept you can always find in those papers, but then that'll take a lot of time for anybody to understand that.
Yes.
You want a easy explanation, so we can check that out if you want to get deeper into that.
Yeah, not some intuitive things, because probably intuitively we understand, but give some mathematical base on that. Say for example, like this bagging reduces the variance, right? Like some mathematical conviction, like why it will reduce the variance.
We'll try that out. That's a good point. We can bring that in. So so far already there were so many things to cover in this week 10. But then this is a good, and I understand this is a good and important point that if added, will be helpful for many people to understand, just not just the intuition, the underlying proofs. So we can bring that in. We can.
Yeah,
Let
so
me.
like I have marked you as well, Amruta, like everyone probably.
Okay, no problem.
Yeah.
We'll check that out. Give some time. There are so many things going on, so everybody is busy. We will get back to you. Okay. All right. So I think you would have done till this point. I think we can now call it off if there are no immediate doubts right now. I hope you were able to make use of these libraries now. If there are any more doubts, you can ask me, or we can call this off. Okay. Thanks everyone for joining. Thanks.
So, ma'am, like for this campus visit, like what are the agendas actually?
So what I know is director, ex-director, and dean will be there, and then initially that's the initial plan, and then after that it will be a session with your feedback and a discussion with the students. I think it's a little open-ended, but for sure there is a set agenda which I don't have in front of me. Maybe you can check that out with the support email. Yeah. Are you planning to join?
No. Like since like it is a very short notice, I cannot. But I was just thinking, like, is there something like interaction with the professor or technical teams will be included in this
So
agenda?
some of the course support instructors will be available, but not all. Yeah.
Okay, and like similar kind of things like will be there in future as well, right?
Yes, that's what is planned. But yeah, I get your feedback that there should be a good, not such a short notice.
Yes, ma'am. Going forward, that will be very helpful.
Very true. I understand, completely understand. It's not easy to make plans.
Even in the G phone, probably like you can ask like, okay, what are the area of interest, like probably why we are visiting, and that way, like if those kind of
Even the agenda of your visit, right?
faculties can be made available, because see, like I have tons of questions,
Okay.
right?
Okay.
Now I go there and I see like, okay, like for those department, like I don't see anyone, right?
I get your point. So you look forward to meeting certain people, certain faculty members, and if they are not there, there's no point coming down, right?
Correct.
I
See,
understand.
for us, the main objective is going there, like to get some more insights, or maybe some little bit more clarification when you will be working
Yeah.
with them face to face, right?
Very true. Very true. So yeah, only a few instructors will be there. So I'll definitely convey this point, the notice thing and the agenda sharing, and who all will be present, so that you can have an interaction. Okay. All right, Rajiv.
Okay.
Yeah, thanks everyone. Thanks for
Thank you.
joining. Yeah. Okay, I think we can call it off. Bye everyone.
Bye.